Hello everyone. My name is Kamila Orynbekova. I am senior lecturer in computer science department at the University Kaskelen, Kazakhstan. A novel recommender system for adapting single machine problems to distributed systems within MapReduce. In introduction, we discuss big data and distributed systems. The growth of big data demands more efficient processing techniques. MapReduce and Hadoop enable scalable, fault-tolerant data processing across clusters. The challenge: adapting from single machine systems to distributed systems can be complex. The problem overview: single machine and distributed systems. Adapting single machine problems for distributed systems is a key challenge. Traditional approaches require time-consuming tutorials and learning. Our proposed solution is to develop a recommender system that guides users in adapting problems to distributed systems using MapReduce. Objectives of the research. Firstly, primary goal: introduce a recommender system for selecting appropriate MapReduce solutions. Key features. First, categorize problems into 5 district MapReduce categories. Uses machine learning. In our case, logistic regression and naive Bayes algorithms was used to recommend the solution. Aims to enhance scalability and efficiency in data processing workflows. We used logistic regression and naive Bayes because these two algorithms are mostly useful for binary classification. In literature review, we reviewed several papers, articles in field of recommender systems. Content-based, collaborative, hybrid systems was reviewed. Use of natural language processing and machine learning to offer tailored recommendations. And previous research emphasized personalized learning in distributed computing environments. The gap in literature is the lack of recommender systems specifically aimed at MapReduce learning. Methodology that we proposed. Firstly, data collection. Problems sourced from books like Hadoop in Action and scientific articles. The total database of our problems dataset of consists of unique 107 instances with various attributes like title, input-output, goal, and etc. Then we expanded our dataset till 523 by paraphrasing the goals of our problems. Then problem categorization. We classified every problem into 5 MapReduce categories based on the characteristics. One problem can be categorized in several groups, in several categories. It is also possible. Feature selection and model training. The next step was TF-IDF factorization of textual data was used, and logistic regression with naive Bayes models are used to classify the problems. We find out that naive Bayes results was high accuracy in most MapReduce categories. Best cross-validated F1 score was 0.99 in Oktamov categories. Logistic regression results was consistent perfect F1 score in many categories, which demonstrates strong performance in recommending solutions. But we used the hybrid approach. Why? Because combined naive Bayes and logistic regression was most optimal gives most optimal recommendations for us. In some categories, most performance showed the logistic regression, in others naive Bayes. That's why we use the hybrid approach. In the result and for evaluation, the system evaluation by F1 score was used, and then the system was tested using expert evaluation and showed promising results in problem-solving capabilities. And challenges. We have limited data set, and for future work, it is the addressed like for generalization and focus on binary classification, potential to extend for multitask problems. In conclusion, contribution introduced a novel recommender system that enhanced the learning process for MapReduce. Successfully demonstrated how machine learning models can adapt single machine problem to distributed solutions. Future work, expanding the data set and addressing multitask classification and potential applications in both educational and industrial environment. This approach may be used in other computer science or data analytic fields in the same way, in the same approach, but if the data will be appropriately collected. Thank you very much. Goodbye.